Hi, welcome to lesson 2, streaming. In lesson 1, we looked at blocking requests to LLM. We request the server sends the prompt to LLM and then waits for the complete response from the LLM and sends response back. So in streaming, we send the request, server sends the prompt to LLM, and LLM sends the response as it processes to the server, and server streams it to the client. The only difference in Spring AI is the method call. In blocking call, we use call method, and in streaming, we use stream method. It's quite simple to implement. Streaming turns a 5-second loading into an instant response that types itself out using the exact same LLM request. If your chatbot takes 5 seconds to respond, users perceive it as broken. But if tokens start arriving immediately, even if the total time is identical, users perceive it as smart and responsive. Streaming is now the industry standard in LLM responses. ChatGPT streams, Cloud streams, your users expect it. It's not harder to implement this in Spring AI. You swap call method for stream, and Spring AI gives you flux string of tokens. The question is, how do you get those tokens to client? This lesson explores three different approaches. The three approaches are: the first one using SSEemitter, then response body emitter, and streaming response body. Here SSE stands for server sent event. Let me now navigate to Visual Studio Code. Let me create a new controller file, streaming controller Java. Let me annotate this as REST controller and add request mapping. Let's define chat client. Also, we need this executor service when submitting the task to LLM. Let me define the constructor to initialize this chat client. Let me define the get mapping. Remove this all suggested code. We need this producers attribute, and we need to specify media type dot text event stream value. This controller returns SSE emitter. Let me change this default value. Tell me about rag in a sentence. Now let's define what needs to be happen when executor service submit method is called. Chat client prompt. Let me reformat this dot user dot stream dot content dot subscribe. In subscribe, we have to define what needs to happen when each token is received. Let me invoke a method which we need to define it. This second line says what happens when the error occurs, and this third line signals end of stream. Let me define this method, remove this, and change this return type to void. Now this emitter should send SSE emitter event for each token. Let me save it, build, run. Let me use terminal for testing. Let me hit this URL. Here you can see a -n flag which we didn't use in the lesson 1. It specifies no buffering. The message I am using here explains Spring AI in a sentence. Let me hit the URL. We should see response in streaming. Here it is. Now let's look at the code once again. When client hits stream chat API here, it creates an SSE emitter. It uses this executor service to call chat client API, and controller thread is freed. All these method invocations are same as in lesson 1, except this we were using call. Now here we use stream. So we defined a subscriber. We defined here what happens when each token is received. When each token is received, we send an SSE event. Each token fires the on next send token. Client sees each token as an SSE event in real time. When LLM finishes, emitter complete will be called and connection closes. So in this lesson, we covered SSE emitter. In the next lesson, we see streaming with prompt template. We'll see you there.